Okay, in this right triangle, I am going to put an angle which we do not know. And usually when in math so far, when we have unknowns for like lengths of sides or things in the equation, we call it x. That's kind of like the standard variable for a length of something. In trigonometry, trigonometry is just a fancy word, that's the study of angles or triangles. What we have is this symbol there, and it's called theta. And typically theta is what we use for an unknown with an angle. So what I would like you to do is put theta, which is just kind of an oval with a mark through the middle. I don't know why it says my projector's overheating. It's just on. Hopefully that goes away. With relationship to that, in a triangle, we have three pieces, okay? One of the pieces is always fixed, and that is the side opposite the right angle is called the hypotenuse. Who's heard that before? Okay, good. The side that is then touching the angle, we call this the adjacent, and we call those legs. The legs would be the things that are not touching. The legs are the things that are the hypotenuse. Okay, so we have adjacent. And then we have the other leg, which is called the opposite leg. Okay. So the ratio of sides in those triangles we describe with the words sine, the full name for sine is S-I-N-E, cosine, which is C-O-S-I-N-E, and then tangent. So there's full names for that. These are the abbreviations. Okay. You may have seen this before. So, ka, toa. Who has seen that? Okay. So, ka, toa is a mnemonic device that's just a way of remembering the ratios. S stands for sine, and sine in a triangle of an angle, so we're referencing this angle here, is the ratio of the opposite piece over the hypotenuse. So the sine is the ratio of the opposite over hypotenuse. So ka, and I encourage people always to write that down at either if you know it in your head or write it down at the top of your paper. The C in that expression stands for the cosine of an angle, and the cosine, abbreviated cos, is AH adjacent over hypotenuse. The tangent, TOA, is the ratio of the opposite over the adjacent. Okay. Now, I know some of you have seen those three ratios before. What I'm going to do is expose you to three other ratios, and they are just the reciprocals, okay? So they are the cosecant. I guess I should have written them the full name out. Cosecant, which we abbreviate as CSC. The secant, and the cotangent. For us today, besides just writing them down in a triangle, we won't do a whole lot else with that. If you take pre-calculus, we will do some more things with it in pre-calculus. Here's what you need to know. I put these next to each other because they are just reciprocals of one another. The cosecant, I know you think it should go with cosine because of the cos, but it doesn't. It is simply the reciprocal of the sine function. So it is the ratio of the hypotenuse over the opposite. The way we take a reciprocal of a fraction is we flip it. The secant is the reciprocal of the cosine function. So this one is hypotenuse over adjacent. I'm just flipping that. And the cotangent, that one sounds right, that's the reciprocal of the tangent function. So we're over the course of this week, we're going to deal with a lot with these three. Today, just writing those other three. Now, you may have noticed also some buttons on your calculator, so that's going to have your calculator out. The sine, the cosine, and the tangent functions are on your calculator, okay? So there's kind of two things that happen. Sometimes I give you an angle and I ask for one of those things, then you can use your calculator because your calculator has the ratio of those for every angle, okay? And every 50-degree angle, for instance, has the same ratio of sine, cosine, and tangent. The thing that we're going to do today, though, is we're not going to use this because we're not going to know the angle. We're going to try to figure out using the sides what the ratios are. So, this involves some Pythagorean theorem. Who remembers that? Just give me a thumbs up if you remember the Pythagorean theorem or you've heard of it before, okay? I guess if you haven't, I'll just write it to the side here. In any right triangle, if we have legs A and B and hypotenuse C, the relationship between the sides is A squared plus B squared equals C squared. So that's just kind of a little reminder in case you need it. Okay, so what we're going to do is I'm going to evaluate the 6 trigonometric functions. I use trig for short a lot. Of the angle theta, which is down here in the corner. And I need to know the opposite, the hypotenuse, and the adjacent. What am I missing? Which piece? Hypotenuse. Let's find it. So I'm going to use the 15 and the 8, and I'm going to find this hypotenuse. I'll call it C. So 8 squared plus 15 squared equals C squared. Corey, here's a note page. All right, let's get our calculators out. 8 squared plus 15 squared, let's put them together. I get 289. Are you getting the same thing? Okay. And is the square root of 289 exact? It is. I get that at 17. You with me? Okay. So, now I'm going to evaluate my 6 trig functions. I'm going to just do the sine first, and then I'm going to do its reciprocal because they are related. We're going to just flip that fraction around. So the sine, written S-I-N, of theta is the ratio of opposite over hypotenuse. So we're going to write the fraction opposite is 8. And the hypotenuse is 17. So we're going to write 8 over 17. The reciprocal of that function is the one right across it. So I'm going to do that one next. The cosecant of theta then would be 17 over 8. Okay, let's move on. Make sure you don't drop out that theta because that is the angle. You're taking the cosine of an angle. The cosine of theta is adjacent over hypotenuse. So the piece that's adjacent is 15 and the hypotenuse is 17. The reciprocal of cosine is the secant, so I'm going to write that one next. And then we have tangent of theta. The tangent of theta is the opposite over the adjacent, so opposite is 8 over adjacent of 15. The cotangent then would be 15 over 8. Okay. Pretty straightforward. I thought what I would do for our second example though, is when we're finding, just to make sure we know how to find a missing side when it's not the hypotenuse. So do you guys see here on this one, I have a leg that is missing. So I am going to first find that leg. Let's do this right here. I'm going to say, I'll call it a squared plus 2 squared equals 5 squared. That's a squared plus 4 equals 25. I need to subtract 25 from both sides. And then I need to take the square root. Okay, typically we write plus or minus, right? But this is the length of a side. So for the length of the side, we're going to leave it positive. And for today, guys, you can just leave them as square roots. Okay, so we can just leave this as the square root of 21 because it's not exact. Like the last time it was exact. Because then I don't even have to bother with a decimal. I'll just leave the square root of 21. Okay. I think we could go from there. Let's just at least do the first 3, okay? Sine. See if you can work ahead of me. The angle again is down in the bottom left-hand corner. So the sine is the ratio of opposite over hypotenuse. And opposite the angle is 2. And the hypotenuse is 5. Cosine of the angle is the adjacent over hypotenuse, so root 21 over 5. And the tangent is the opposite over the adjacent, so 2 over the square root of 21. Okay, who had geometry last year? Okay, some of you who had geometry last year, your geometry teacher might have taught you then you could rationalize the denominator. Do you remember them having you do that? Multiply top and bottom by root 21? No? Sounding familiar? Okay. For what we're doing today, you can just leave the square root of 21 as is on the bottom. So, all right. So that's how you find, if I give you triangle, you find the missing piece, and then you write the ratios. The second example that we're going to do today, I think those are our only 2 then. Yeah. The second example that we're going to do is, what if I give you one of the angles, and I ask you to find some other pieces, okay? It's very similar, except you're going to have to draw your own triangle. So let's draw a triangle with a right angle. I'm going to draw it this way this time. I don't know what the triangle is called, but I know there's an angle B, okay? So your pick, you either here or here, you're going to put angle B somewhere. And this is the angle of reference. Since I told you that the sine of B is 3 over 5, what's the ratio of sine again? What to what? Opposite over hypotenuse. What we're going to do is we're just going to use the ratio 3 over 5, and we're going to put the 3 in the spot where the opposite would go. So here's angle B. I look across to the other side, and angle B, the opposite would sorry, the opposite would be a 3 over hypotenuse, so that 5 is going to become my hypotenuse. All right, what am I missing? I'm missing a leg. Would you find this leg, please? Use Pythagorean theorem and find it. All right, so hopefully you got that missing piece was a 4. Okay, so once again, remember my angle is here in the bottom right corner this time. I asked you to find the cosine and the tangent. The cosine of B is the adjacent over hypotenuse, so we're going to write 4 over 5. And the tangent of B is the opposite over adjacent, so we're going to write 3 over 4. Okay.